So, Jai Hind to all. Today I am here to discuss a very important topic of computer network. The code of this is BCS 603 in the AKTU syllabus, and this is the very important course that is that run in almost all the universities, technical universities in the BTech courses as well as in MTech courses also, BTech, MTech and MCA. So, this is the third unit that is known as the network layer and IPV4 header. Okay. Myself Dr. Santosh Upadhyay, Associate Professor in CSC Department in AKGEC, Engineering College, Ghaziabad. So, let us see network layer. As we know that before going to the network layer, we know that there is the 7 layer in ISO SI layer model. Okay. ISO OSI layers. So, they are the 7 layers. Okay. They are the 7 layers. What are the 7 layers? We know that there is, if we top out the top to bottom, then there is application layer, presentation layer, third one is session layer, you got it? Application, presentation, session, and the fourth one is, transport layer. Is it visible? And the fifth one is network layer. Sixth one is data link layer. And the bottom layer, that is the seventh layer, that is the physical layer. Okay. So, these are the 7 layers which is given in the OSI model, and this is the base for any computer network. That means all the computer network responsibility and functionalities can be divided into these 7 layers, in these 7 parts. Okay. This is the layered approach. That means each and every layer has its own responsibilities, its own capabilities, its own functions, and so by using these layers, we can easily identify if there is some mistakes, there is some problem, there is some bug, at which layer this is lies basically. Okay. So, here we are talking today this one, fifth layer, that is network layer. Okay. That means when data generated from the applications, different applications are the user, that is generated by the application layer by using the different kind of application layer protocol like HTTP, DNS, FTP, SMTP. There are the number of protocols, okay, by which we can generate the data. User can generate the data to send from sender to receiver. Then this generation is, this data is presented by some protocol, some algorithm, and that responsibility is given to the presentation layer. That means at this layer, the data is compressed. If the large data is there, then that is compressed, or that is encoded, encrypted for the security reasons. Okay. So, these functionalities basically that is data compression as well as data encryption is done at the presentation layer. Then there is session layer, third one. A very important session layer means there is a session, a dialog box that is established between user, means between sender and receiver. Okay. So, this is the responsibility of the session layer to establish a session that start session, and after communication within a fixed time period that will close the session. Okay. So, that is responsibility of session layer to establish a dialog box in which during which that particular sender can send the data to receiver. Transport layer. The function of transport layer, as we know that This is the process to process communication layer. That means this is the layer that ensure that your data or information is delivered end to end delivery. That means from process to process. What is the meaning of process to process? Actually, we know that at same host, same machine, same computer, there is a number of process that are running. Okay, that some process of mail transfer is running, some process of web browsing is running, some process of file transfer protocol is running. There are a number of process are running. Okay, so when sender send a data related to the file transfer, there is a process running on the sender for the file transfer. So that data should be delivered at the receiver end to the FTP process. Okay, so this process identification is done by the port number. So in transport layer, this is the this have the IP address as well as the port number to uniquely identify the process. So from process to process delivery is done by the transport layer by using two protocol, as you know, that TCP and UDP. We will discuss in some other lecture. Network layer. Network layer is also known as the logical addressing. Okay, so this is basically the concept of IP address. By using the IP address, different devices or computing devices like router, like computing node is identified on the network. Okay, so this ensures the delivery of the packet from source to destination node. Okay, then data that the output of this network is given to the data link layer. Then that is data link layer use the MAC addresses to identify the different machines, and then finally the physical layer, by using the physical layer, that is transmitted over the transmission medium in the light form or in electrical signal form. Okay, so now we are here to the network layer. Okay, so we are discussing the network layer. So the network layer is the third from bottom to top. If we talk from the bottom to top, that is the third layer. Okay, here we can see that first, this is second, this is third layer. Okay, so this is third layer. The network layer is concerned with the delivery of the packet across the multiple networks. Okay, the network layer is considered the backbone of the OSI model. It select and manage the best logical path for the data transmission between the node. This layer contains hardware devices such as router, bridges, hubs, firewall, switches, but actually create a logical image of the most efficient communication route and implement it with the physical medium. Network layer protocols exist in every host or router. The router examines the header file for all the IP packets that pass through it. In the OSI model, the network layer responds to the request from the transport layer and issues request to the layer just below it, and that is the data link layer. Okay. So, if we talk about the responsibility of the network layer, then packet forwarding and routing of the packets. This is the very important roles of this particular network layer. As we know that in network, there the number of addressing will be taken place. Okay, application level addressing by using the application like domain address .edu, .com, like that. Then process level address by using the transport layer. Okay, by using the source ID, source IP address plus port number. Then the logical addressing that is done by the network layer. Okay, in the form of IP addresses, IPV4 and IPV6. Then there is the data link layer addressing, that is the MAC addressing, MAC layer. Okay, so MAC address is also used to identify different particular machines. So the data that is treated at the network layer is known as the packet. Similarly, as we know that at the transport layer, that is known as segment. at the data link layer, that is known as frame. At the bottom, that means a physical layer, that is known as bit stream, or byte stream. Okay. So here packet forwarding and routing of packet is a very important role of this network layer, because there is a number of router in the network. So each router or computing machine, whenever accept any packet toward it, then that examine the source destination IP. If that is matched, then receive, otherwise that is passed to the other possible link, that is the most optimized link, by using the routing tables. Okay, there are the number of routing protocols that work here at the network layer. Connectionless communication. So this is IPv4 is the connectionless protocol basically. Okay, connection oriented means when there is a three-way handshake before starting the communication, like TCP IP protocol. That is the TCP protocol is, that is the connection oriented protocol. Fragmentation of data packet. So one data segment is coming from the transport layer, that is fragmented into small size packets, that is more manageable. Okay. So there are the two type of network transmission technique here, circuit switch and the packet switch. As you know that in circuit switch, there is a dedicated link from source to destination is established, and all the packets follow that route. And in packet switch network, the different packet of a same message can adopt different possible free route from source to destination. Okay. So there is a chance of out of order delivery, and this is a in order delivery. In order means all the packet are received in order. Here may receive out of order. Okay. So there is a very important functionalities of this network layer, that is the packet forwarding and routing, connectionless communication is there, fragmentation of data packet, and this communication can be managed into two forms, circuit switch and as well as packet switch. Here there is a two most important protocol for the addressing purpose. Okay. Here are the protocol, two or three protocol that work here, basically TCP, IP, UDP. Okay. So UDP and TCP protocol work at the transport layer. This IP protocol work at network layer. Okay, network layer. So these two at the transport layer, IP at the. So IP have the two version, IPv4 and IPv6. Okay. So here, as we know that whenever any data is sent from source to destination, what happen? There is a number of layers. Each layer has its own work, its own functionalities. So whenever data is passed from top application layer to the physical layer, then in successive way, each layer add on its own information, and that is known as the header at that layer. Okay, that means application layer maybe its own header, this TCP that means transport layer has its own header, network layer its own header, data link layer has its own header. So header means that contain the metadata. Metadata means the data about the data which is sent from that layer. Okay. So their description is there basically, because you know that each layer had its own protocol. Okay, just like IPv4 protocol, IPv6 protocol, TCP protocol. So how these data is handled or controlled by according to that protocol. So that protocol information and their metadata, their description is given in the form of header format at that layer. So, similarly, whenever network layer attach its header, so that header is of maybe IPv4 header, or if it is using the IPv6 version, that is the IPv6 header. Okay. So, that header contains the different kind of information, how this data is treated, how this is controlled at that layer. So, IPv4, so Internet Protocol version 4. Okay. So, IPv4 is a connectionless protocol. So, basically IP is a connectionless protocol. Okay. There is no handshaking, or there is no handshaking process before establishing the connection. Okay. So, just whenever sender have the data, that send the data. There is no connection establishment, there is no connection termination. So, that is why this is known as connectionless. Unlike TCP, packet switch network, it operates on a best effort delivery model in which neither delivery is guaranteed nor proper sequencing or avoidance of duplicate delivery is assured. Okay, this is the packet switch network. As I have already told you, whenever you use packet switch, what does it mean? It means each and every packet, or you can say the packet of a particular message, can follow different possible route from source to destination. Okay. That means different packet of the same message can follow the different routes. What it mean? That means at the receiver side, a packet which is sent prior can receive later. Why? Because there may be congestion at that path which is followed by the first packet, and it may be that the second packet can be delivered before the first packet. Why? Because the second route that is followed by that second packet is congestion free. Okay. So, that is smoothly delivered at the receiver. So, that is known as the out of order delivery without sequence. Data can be, a packet can be delivered without sequence. So, that is a problem. Other is that it is not the guarantee that packet will be received, because this is the connectionless. So, connectionless is that is not a reliable service, not a reliable service. Connection oriented is always a reliable service, where you can rely that the data is received at that particular destination, because there is acknowledgement facilities. Okay. Whenever data received, a particular acknowledgement is given back to the sender. Internet Protocol version 4 is the fourth revision of Internet Protocol. That is why this is the version 4, IPv4. The IPv4 is IP1, IP2, IP3 is not the commercial, basically that may be used in the lab or at the during of development phase. They release the IPv4 that is commercially accepted, and still nowadays also that is used. Okay. So, this is a widely acceptable and usable protocol. IPv4 is a connectionless protocol and that work in the packet switch mode. Okay. It provides a logical connection between source and destination, and that provide the logical addressing like the IP addressing, IP address. Okay. IPv4 basically provide the 32-bit address. This is very important, that provide the 32-bit address space. Basically, this is known as the IP address. Okay. And these IP addresses is divided into number of classes, basically in 5 classes: A, B, C, D and E. Class A, B, C have the different bit length for addressing in the network host. Class D address are reserved for the military purpose, while the class E address reserved for the future use. Okay. This is the specification of ABC. ABC is used by the most of the person, and the D is for the military purpose, and the E for future use. IPv4 uses 32-bit address, that is the 4 byte basically. That means that provide the how much address? 2 to the power 32. This is the combination. That much different kind of number can be generated, that can be assigned to the different devices. So, this is the maximum number of addresses that is generated by the IPv4, 2 to the power 32. IPv4 addresses are written in a dotted decimal notation, okay, and which comprise basically 4 octant. Octant means 8 bit, okay. So 8 bit, 8 bit, 8 bit, 8 bit. 8 4 ja 32 bit. So there is a dotted notation like this, this 200.10.21.5. So this is the example of IP address, IPv4 address basically. This is known as dotted decimal notation, okay. So this is the first octant 8 bit, this is the second octant 8 bit, this is the third octant 21 8 bit, and this is the last fourth octant 8 bit. So how many bits are there? 8, 8, 8, 8, 32 bits are there. And this is known as dotted, dot is there, and decimal means these number are written in decimal, okay. So whenever you want to convert in hexadecimal or you want to convert in basically binary, so you can convert 200 into decimal or or binary or hexadecimal, whatever your requirement. This is basically the decimal, dotted decimal notation. IPv4 header, this is very important, as I have told you that these information or header information are the layer functions. What are the functions of layer, how that work, how that control the data. These information is packed into a data packet, you can say the small packet, that is known as the header basically. This is also metadata about the data, how the data is controlled. So IPv4, this is the header format of this IPv4, okay. So there are the how many? 1, 2, 3, 4, 5, okay. 5 octant are there, okay. 5 row are there. This is of how many bit? 32 bit means 4 byte. So this is of 4 bytes. This is also of 4 bytes. This is also of 4 bytes. This is similarly 4 bytes. So this will be 20 bytes, okay, 20 bytes. This last row are optional, that may be or may not as per your requirement. This is known as the options plus padding. This may be from 0 to 40 bytes, okay. This is the additional optional bit. So similar to how can you decide what is the size of this header, what will be the size of header. So there is a range, okay, because these 20 byte, these 20 bytes are necessary, that should be there always, and this last 0 to 40 bytes are optional, that may be 0 or maximum 40. So what is the range? The range will be 20, because 20 is means 20 is compulsory, okay. These 5 rows should be always should be there. So 20 byte 2, and in the maximum cases this may be option of 40 byte is also there. So this will be 20 plus 40, that means 60 byte. 60 byte, okay. So IPv4 header is of range to 20 to 60 byte, okay. 20 to 60 byte header, and there is a payload, okay. And this total information may be 20 to this one byte, 65, the 535, 65,535, okay. This is 20 and maximum this payload 2 to the power 32, 2 to the power 16 basically. This is the 2 to the power 16 minus 1. Why 2 to the power 16? We will see here, because the data size will be 2 to the power, data size will be of 16 bit, okay. So let us see in detail what are the information that is contained by this particular IPv4 header. So this is the first one, is the version, that are 4 bit, were field in first row. Then the second field of the first row h length, this is the header length of 4 bits. So this basically this is the 4 bits, okay, and then service type of 8 bits, total length of 16 bit. This is the total length, okay, 16 bit means 2 power 16. That's why this header plus payload total is of IP datagram size maybe maximum 65,535. Okay. Second row identification bits of 16 bit, and then next 16 bit is divided into flags of 3 bits, very important, and then fragmentation offset of 13 bits. This is the TTL information, time to live, 8 bit. Okay. This ensures that up to how much duration your data will be live during the communication. After that, that is useless, that can be dropped. Protocol of 8 bit, then header checksum for the error control, error detection of 16 bit. Then this fourth layer or fourth row is IP address of 32 bit, source IP, and the last one the destination IP of 32 bits. Okay, and this is the option information, like you want to compress or some other basic information you want to give. So that is here you can provide. Version number, this is the 4 bit number. Okay, that basically decide the, this is the of version 4. Okay, so this always contain this 0100 like information. This value is 4 now in decimal. So this is the IP protocol, a format of version 4. That means IPV4 format is there. Header length is a 4 bit field that contain the length of IP header. What is the size of IP header? That is given, that is mentioned in the this HLN field. HLN, header length. Okay, it helps in knowing from where actual data begins. Okay, that means this is the number of bits for header, and from this start the actual data or payload. Minimum and maximum header length, we know that minimum header length will be 20 and maximum will be 60. So basically this header information always multiplied with the 4. Okay, this is the known as the scaling factor. So what information is there in header field by using 4 bit, like 0 1 1 0, yeah, like 1 1 1, this one. Okay, so what information is there? That is always multiplied by 4. So this is 15 basically, 15 multiplied by 2 equal to 30. That means the header length is of 30 byte. Okay, because when you only use the 4 byte information, so this can maximum present by, you know, how much? All the 4 ones. So what will be there? All 4 ones. So this is maximum 15, na? 1, 2, 4, 8. Yes, and this is basically not this is not 15, but this is the 7 value, na? 7 2 ja, 7 4 ja, basically 28. So header length will be of 28. Okay, so this is the header length. The value of header length is always multiplied by 4. This is the scaling factor, 4. Then other is the, for example, suppose if header length field contain this information 101. So 101 is basically, if you convert in decimal, this is the 5. Okay, so this 5 is always multiplied with the 4 scaling factor, that gives the 20. That means the header length is in this particular data 20 byte, and after 20 byte the data payload will be considered. If header length contain decimal value 10 represented by this one, then header length will be not 10, 10 into 4, 40 byte. So, this is the example. Then the service type, okay, that provide the TOS type of services are differential services and total length. So, these are the basic very important example, and the next of this, by using the particular example, we will explain in the next lecture. Okay, thank you.